Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this video we will discuss about iterator design pattern. What is iterator design pattern? Where to use iterator design pattern? And I'll also show you the Java code implementation of iterator design pattern. At the end we will discuss the benefits of iterator design pattern. So stay tuned till end of the video. Friends, in the previous video we discussed about interpreter design pattern. Can you explain what is interpreter design pattern and how to use it, where to use it? Please reply your answer in the comment section. If you have not seen that previous video, so I recommend you to go and see that video. That's very important design pattern. The link is given on your screen and also provided in the description section. Just to recall interpreter design pattern lets you evaluate an expression in a language as per provided grammar. For more information, please go and see previous video. Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you. Okay friends, now let's start with the iterator design pattern. Iterator design pattern is a type of a behavioral design pattern that lets you traverse the element of a collection without exposing its underlying representation. Confused? Not clear? I'll explain. So consider a list, stack and tree. We can iterate element of these objects without knowing the underlying details of list, stack and tree. The iterator design pattern provides a way to access the element of an aggregated object sequentially without exposing its underlying representation. The iterator is one of the simplest and most frequently used design pattern. The iterator pattern allows you to move through a collection of data using a standard interface without having to know the detail of internal states of that data. Let's take an example of different types of collections we have in Java language. Collections are one of the most used data type in programming. A collection is just a container for a group of objects. Most collections stores their element in simple list. However, some of them are based on stack, trees, graphs, and other complex data structure. But no matter how a collection is structured, it must provide some way of accessing its element so that other code can use these elements. There should be a way to go through each element of the collection without accessing the same element over and over. This may sound like an easy job if you have a collection based on list. You just loop over all the elements and done. But how do you sequentially traverse element of a complex data structure such as tree? One day you might be just fine with depth first traversal of a tree. Yet the next day you might require breadth first traversal. And next week you might need something else like random access to the tree. Adding more and more traversal algorithm to the collection gradually blur its primary responsibility, which is efficient data storage. So we have to take this concern out of our collection storage and make it efficient. How can we have a traversal algorithm defined separately and storage defined separately? So the solution to this problem is the iterator pattern. The main idea of iterator pattern is to extract the traversal behavior of the collection into a separate object. We call it iterator. In addition to implementing the algorithm itself, an iterator object encapsulates all of the traversal detail such as current position, how many elements are left till the end. Because of this, several iterator can go through the same collection at the same time independently of each other. All iterator must implement the same interface. This makes the client code compatible with any collection types If you need a special way to traverse a collection, you just create a new iterator class without having to change the collection of or the client code. Okay friends, let me show you the code implementation of iterator pattern. I have prepared a code for you. I'll show you the code first and then I'll run the code and give you the demo. Let me show you the code first. Friends, I have shared this code in my GitHub repository. You can download the code and play with it. The link of my GitHub repository is shared on your screen and also available in the description section of this video. So you can download the code from there and play with it, right? Okay, let me show you. So I have a package iterator where all my classes are there. Then what I've done is I've defined my domain object, let's say customer. In this customer, I just have a customer name and the customer code and respective getter and setter method. Nothing fancy here. And I want to write a iterator so that I can manage a list of a collection of my customers and do all the operation like add a customer, get a customer from the list, go to the next customer, go to previous customer, get me the total count of customer in the list. So I will write one iterator class, right? I have written one iterator class and here I have defined what is my current index, like it always starts from 0. Then I have defined a list of customers. So this is a collection of my customer where I will be storing all my customers and then will do iteration on this collection like go to next, go to previous, get me all customers or get me the count of customers and so on. So this is my list of customers. Then I have defined methods to perform operation on this list. So let's say add customer. In this method, I'm passing a customer object and I'm adding that customer to this list, right? Now I have another method get total count. This total count method get me the total number of elements I have in this list, total number of customers I have in this list any moment. So this is to get me a total count. Then I have defined another method get by index. So you pass an index, then you get element from that index, okay, from that list. Then get previous. So based on the current index value, minus the index by 1 and then get that element. Get next means whatever the current index you have, then you increment that index by 1 and get that element. Then get first will give me the first element in the list, get last will give me the last element in the list, and get me all the element of the list. So these are some very basic methods what we have written to iterate easily on a customer list. This is a very simple example of iterator. And the same iterator you could see that Java has implemented. They have provided iterator class that works with any collection types, be it list, be it set, be it tree, or any collection type. It is a very simple example of similar kind of iterator. Then I have written a test class where I am defining an instance of iterator and then I'm creating multiple instances of my customer 1, 2, 3, 4, 5, right? And then using iterator, I'm adding a customer 1, add customer 2. Then here I'm getting a total count and printing it. What is the total count of customer at this moment? Then I'm adding a customer 3, customer 4 using iterator. Then again, I'm taking a total count. Then I'm going to the next customer. Remember, our index starts always from 0. So now the index come to picture. So it will show me the first customer at this moment. Then it will show me a second customer at this line. Then again, I'm adding a customer. The total customer has increased. Then I'm printing at the count. And again, I'm going to the next customer. Then going to the previous customer. Then going to the first customer. Going to the last customer and printing it. Let me run this and see what happens. Yeah. So here you see all the logs are printed. Customer added successfully. Then customer added successfully. Then total count. Total count is 2 at this moment. Then this customer added, this customer got added, then total count become 4. Then getting the next customer at index 1 because index starts from 0. So now it become 1 after incrementing. So we got that customer from index 1, then we got customer from index 2. Then we added a customer again in the list, another customer we have added. Then the total count become 5. Then we are getting the next customer, the index become 3. Then going to the previous customer, then index become 2. And then getting the first customer and getting the last customer, right? So this is a very simple example of iterator. You can write wherever you want to have your custom ways of iterating your collection, you can create similar kind of iterator class. So friends, what do you think? Where can we use this design pattern? Do you know where is the implementation of this design pattern? So let me tell you. Whenever we have a standard way to traverse through a group of objects, that time we can use this pattern. Whenever we want to traverse element of a collection without exposing its underlying representation, that time we can use this pattern. Whenever we want to add more traversal algorithm in future to the collection and want to keep traversal logic separate from the collection data, that time we can use this pattern. So that both your traversal algorithm and your collection logic can change independently. So what are the benefits of iterator design pattern we get? The same iterator can be used for different aggregates. Different iterator algorithm can be used on the same collection at the same time. Allows you to traverse the aggregator in a different ways depending on your need. It encapsulates the internal structure of how the iteration occurs and don't need to bloat your class with operation for different traversals. Friends, let me summarize what we learned in this video. We learned what is iterator design pattern. We saw real examples of iterator design pattern. We also saw the Java code implementation of iterator design pattern, and we also understood the benefits of iterator design patterns. Friends, let me know if you have seen this pattern in your project or came across a scenario where this pattern can be useful. Please provide your answer in the comment section of this video. Friends, in the next video, I will cover chain of responsibility design pattern. In next video, we will learn what is chain of responsibility design pattern, where to use chain of responsibility design pattern, how can we implement the chain of responsibility design pattern in Java, and we will also see the benefits of chain of responsibility design pattern. So stay tuned for the next video and do subscribe to this channel for the latest videos on technology. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.